Hello everyone, and welcome to the second video of this series about derivatives and integrals. In this video we are going to be tackling product rule, chain rule, and quotient rule. But before we start, I want you guys to sort of just memorize these for next time. So we have the integral and derivative of e to the x, sine x, cos x, ln x. So these are all special functions we didn't cover in the first video. 1 over x we actually did, because that's just x to the negative 1, so that's just power rule right there. But anyways, we're going to dive into the video now. So the first thing we have here is product rule, this thing. What it's basically saying is if I have two functions multiplied by each other, here's how I would deal with that sort of. I'm just going to give sort of like a basic one to start, x e to the x. If we wanted to differentiate this, now, no, this does not work for integrals, and I'm specifically only doing derivatives right now because integrals get a lot trickier, okay? But we're going to do exactly what this thing says. Differentiate the first function. The derivative of x is 1. Keep the second function. Add. Keep the first function. Differentiate the second function. We know the derivative of e to the x is just e to the x, right? So, in the end, we can factor out e to the x, and we are left with 1 plus x right here. This would be the solution. Alright, so now that we've covered sort of how to use product rule, I wanted to derive chain rule for you guys, because it's a pretty cool derivation. So what this is saying is, if you have sort of a function inside a function, like if I had sine of x squared, for example, right, the x squared is in the sine. That would be different from sine squared of x, where the sine x is inside the square function, right? Those are two different things. And this chain rule helps us deal with that. So the way chain rule works is we have this d over dx of f of g of x, right? You can see I've written that there. But we're going to say g of x is equal to u. So in other words, we're going to have this. Now, how do I differentiate f of u with respect to x? Like, there's no more x in the function, right? But the cool thing is here, we can rewrite df over dx as df over du times du over dx, right? You can see the du's cancel. That's sort of abusing notation. Obviously, it's not as simple as that, but you get the point. We can now differentiate f with respect to u and multiply that by the function u with respect to x. So two different derivatives being multiplied by each other. So what is f of u? Well, going back to our sine of x squared, what this is going to look like is essentially sine of u, right? This is going to become sine of u. And how do we differentiate sine of u? Well, we set it right here, right? It's just cosine. So we're going to have cosine of u. And we're going to multiply that by the derivative of the inside function. Our inside function is x squared. The derivative of x squared is 2x. Now, remember, u is really just x squared. So in the end, we're going to have 2x cosine of x squared. And that is our final answer. And that is how you use chain rule. Now, we are going to use product rule and chain rule to derive quotient rule, okay? So, really, right, this is going to just be f of x times 1 over g of x. If you think about it, right, it's just multiplication. At the end of the day, fractions are really just division, right? It's the same thing. So, but this is actually chain rule because it's sort of the function 1 over x combined with the function g of x, right? And we just learned how to deal with a situation like this. So we're going to say that this is equal to f prime of x, and then, you know, that can be times g of x. Sorry, 1 over g of x. And then that would be plus f of x, and then now we would differentiate 1 over g of x, right? And how do we differentiate this? Using chain rule. So the first thing we're going to do is differentiate the outer function. The outer function is 1 over x. We know the derivative of 1 over x is negative 1 over x squared. So g of x squared, like that. And that's going to be multiplied by the derivative of g of x, which is just g prime of x. Okay, so then, in the end, we are left with f prime of x over g of x plus f of x, or rather minus f of x, g prime of x over g prime of x squared, which, if we want, we multiply top and bottom by g of x, right? So we get f prime of x, g of x, minus f of x, g prime of x, sorry for the little space, over g of x squared. And this is the formula you would see in like a textbook. But now you know how to derive it. And honestly, quotient rule is useless if you know these other two. So anyways, that was today's video. Goodbye.